couple more things that I remember to say during the break. Let me do another demonstration on the pointer semantics. Let me actually add an operation here. I'll say, okay, we have some operations, and we could could have an operation saying void nullify. And basically it will say equals null. Just set this thing to null. By the way, the compiler will probably not know what null is. I think I need to include std def to define null. Yes. All right. So what I just did, I said, let me have some, an operation which would yet add some other, cumbersome and questionable usefulness to this particular class, which is already doing a lot of dangerous things and not very clear how to use it properly. But it is what it is, and so let's add another function. All right, so added that function. So to demonstrate, if I wanted to call this function, and I have a couple of terminators here, Alice and Bob. If I wanted to call foo on Bob and Alice, if I wanted to do exactly this and say terminator, I can say nullify, right? So this is how I would call a member function of TRM using the reference. Right? Any questions about this? Again, this is member dereference operator, which basically says, okay, this is an object. It has a member function, so let's call it. Let's make a call into it. Another demonstration. And by the way, I do make these calls. Right? So let's actually save everything and say build. So Control F5, run it, so it runs fine. Okay, let's modify this a little bit more and add another function, overloaded. So this program no longer crashes, right? So all right, so another example of a function that takes a pointer. All right, so another example of a function that takes a pointer. Since we're dealing with a pointer, this syntax no longer works, unfortunately. So we have to we must dereference the pointer, right? If this was a pointer to the terminator. Now, this was a good demonstration right here that once initialized, a reference behaves exactly as the original object, right? So we had Alice and Bob, and you could say Bob dot, nullify and do all this. That would be very simple. Here, exact same simplicity of making calls into member functions. With the pointer version of foo, and so let's perhaps call Alice with the pointer version. Automatically, we can say, okay, take address of Alice, right, and make a call foo. So this time, the call will be directed to here because call resolution rules will say that this is the most appropriate call to make when the programmer says something like this. So this is being considered ugly because, listen, functions take pointers to objects all the time. All the time, most of the time, we don't want to be manufacturing copies of our objects. And yet a lot of programmers choose to use pointers as a parameter as opposed to the reference. So therefore, this ugliness has to be dealt with, that you need to remember to dereference the pointer. So one of the nicer ways of doing this would be to say there is an alternative syntax to this, using a pointer to member dereference operator, which basically, which uses this syntax using dash and an arrow-like formation of dash and greater than punctuation, which essentially basically says I have a pointer and this is a pointer to an object, and so let's call this using the pointer. Let's make this call. So very simple alternative. Those two things do exactly the same thing. It's just like sugar coating. It's just the syntax I wanted to show you. With objects, when you have a pointer to an object, you can use this operator, which automatically makes a call, resolves which member function to call, but also instantly dereferences the pointer, because the pointer is being used to access a member function of an object, to make a call into it. So hopefully, so I just wanted to mention that. And finally, one little demo to show you that recall that, and I may use this particular function to demonstrate this, since this really didn't make any sense. Suppose that I change my mind and I decided to use a reference. I'll say ref. All right. So I want to actually use a reference in this particular function that has no purpose, just for the demonstration purposes. I have two integers and I want a reference, and so then I can basically what I need to change is that I no longer need to take address of a variable. And then, of course, I changed its name to a reference, a ref, right? So now I don't need to dereference the reference variable. I can use it directly. Agree? So this is, now I'm using reference. This is a reference. So then also I can no longer, or I'll just use a reference here as well. So let me get rid of this and let me essentially show you something here. What if I wanted to say, I don't know, Boolean flag? What if I wanted to provide a Boolean flag and say, if, so the idea is this: if flag is true, right, then I want my reference to point to a dummy, just something that I already have. Otherwise, I want my reference, sorry, I said pointer. I want my reference to point to silly. And then I want to use my reference to assign brand new, like this nonsense value to one of these variables. How can I do this? How can I control initialization? Remember, this becomes a problem. I want to use an if statement to control how to initialize my reference, on one hand. On the other hand, I have a problem, because now I have this initialization statement and this initialization statement, and now ref and ref remain in scope of these if statements. So I really can't use it outside. But I would like to use a Boolean flag, true or false, to switch initialization of my reference from one or the other. because it appears to be that the only way you have is to, if you create a standalone reference, then this is your only choice, right? So let me